back in, everyone. Thank you for staying with us tonight. We are joined by Jeremy Jabari and Josh Hamilton, a couple of PhD students from the University of Maine. Gentlemen, thank you for being here tonight.
Thank you. We're excited.
Okay, so we're here to talk about your new AI program that's designed to help with breast cancer detection. Tell me about it.
Well, it's really exciting because we showed that by adding context to the model, that the surrounding tissue, the model is able to do better and find cancer where it could easily be missed.
Okay, break it down a little bit for me. What does this all mean? Adding to the model, what are we looking at?
So typically, like neural networks will have just one input, like a very high resolution, but medical images are really large. And so what we did was we added a second image that included the very detailed, what we call context. So it's surrounding tissue and whatnot. And when you pass both those to the model, it finds cancer much better than just passing one.
Okay, so how is this going to be used? How does this help doctors? Is this a secondary tool? How does this work?
I can jump in on that one.
Please.
So like in the US, we have about 85 pathologists per 1 million people, and pathologists are the gold standard diagnosing cancers. You might get screened, but you need a biopsy to actually diagnose the cancer. So the tissue that Jeremy's talking about was from cancer biopsies or tumor biopsies that they don't know exactly what it is. Pathologists will look at it under a microscope. Nowadays, they scan it, and it's all on the computer. Those are the types of images we're using, and they look in and zoom in and look at the cell nuclei and different types of cells and try to predict what type of cancer it is. But there's not enough pathologists worldwide. Some countries have as few as 3 pathologists per 1 million people, which is not enough. So there's like 2 strategies that we think a model like this could help with: triaging patients, which is kind of saying, hey, this patient is at higher risk. We think there's something wrong with this patient. Let's have the pathologist look at this patient first. Or if, as a second reader, usually you have 2 pathologists to say a final diagnosis, so it's not only one person looking at it. So the AI could help with this second reader and assist with every pathologist diagnosis.
Tell me a little bit about how this AI came to be, how this program came to be with you guys.
So it started as part of my PhD research. One of my co-advisors was working on it, and then we were working on ideas and whatnot, and then Josh and I are in the same research lab. And so we started working together and brainstorming together, and really, this is what really I enjoy about research, is not only are we developing a tool that can help people, I enjoy the people that I work with. The late nights, the laughing with Josh, the challenging each other. It's so much fun. And so it came out of us working together.
And the helping people, I really want to touch on that. Is that why you created this tool? Tell me about it.
I originally came to Maine because I liked a special type of math. It brought
Okay.
People thought I was crazy. I'm originally from San Diego.
Wow, you are crazy.
And Andre Khalil, our mutual co-advisor, he works a lot with medical images. And he goes, oh, I do this in medical images. And so that's how I got involved. And I really, like I just said, enjoy working with them. And so not only can I work with people that I enjoy, I can help scientific progress move forward.
Okay. Well, gentlemen, thank you so much for being here. We really appreciate your time. We'll be back after the break with your full 5-day forecast.